So in the last video, I worked on creating basically an outline of a frame um, for the paintings that I have back here. Um, it turned out okay. The support is absolutely awful to get off. I've used needle nose pliers and cut my fingers to the point um, where they're almost blistered. So I think there's probably a better way to do this. So I'm gonna kind of walk through how I might make improvements. I also printed a secondary piece that kind of pops into there so we can cover it up. I don't really like it. I think I can probably do better. I'm just gonna walk through that process. This is gonna be more of an informal, maybe a kind of like a podcast. I'll just talk about whatever I'm thinking, work through this. You can see it's pretty fun because the sun is hitting me right in the damn face. It makes working from home just excellent. So we'll create a new design for this. Teams open. I don't need my OneDrive. You can see I'm working on my thesis. It's a long, terrible, drawn-out process. Okay, so first let's get our grid right. I'll work with the MakerBot. It's weird that these are these the only, oh no, they have a bunch. Oh, they look like they're all hobbyists though. Okay, so I'll update the grid. Usually I would draw a solution, so I think this is actually what I do. Half inch maybe on this last one. Yeah, I did half inch. Actually, I kind of like the half inch thickness, so let's go ahead and get that. And then we'll go, let's say 4 inches. We'll go 5. 5 by 1.5. So then I can also create, let's cut corners off of this guy too. I'm going to do this in kind of a weird way. So we'll go 45 degrees, make this bigger. I think if you hold shift, it probably, yeah, there you go. If you hold shift, it holds it at a constant rate. So in this case, I'm going to go use my snap grid to cut the corner off of this. If some of my, oh, I couldn't quite get that. What I was saying, if some of my CAD instructors from the past saw me not only using a tool they probably think is meant for kids, but also the strategies that I'm using to do all this stuff, they would probably have a stroke. That looks pretty good. So I combine these. Yep. Okay, so I'll copy and paste this. Rotate it at 90 degrees. Wonder if there's a way to flip it. Whatever, I can just rotate 180. Accomplishes the same thing. And then rotate it 180 again. So now I can overlap these two corners. Let's go ahead and do that. Combine these guys. Great. Looks like it didn't lay flat. And it didn't. Looks pretty good. Quarter-inch hole. There's probably a better way to do this, but I'd like to center that. And that looks about centered. Great. And then finally we'll create ½ inch up. Actually, we'll go down. We'll create the absent space that is going to be a painting. So if I've done this right, looks like I'm on that grid. It should be, let's see, one more down there. Looks pretty good to me. All right, I'll export that piece. Fabulous Lulia Kasi. I like it's got the hyphenated last names, like the mom of this piece was, you know, whatever, Lulia. Very progressive. Okay, and then on top of that, I'm also going to make the other piece that goes along with this. So back to TinkerCAD. I'd like to make a plug that goes in the corners, and I figure I'll just print them both at the same time. I had issues with printing with that support material, so I'm just not going to worry about it. We're going to change our design to work around it. So I'm going to make something like this. Create a new design. I like the idea of making a pyramid here. Except this is going to kind of suck to print. We'll try it though. Where's my MakerBot software? So hopefully this mitigates some of the problems I had with that much support material. Now there's just support material under the cap. So let's print one of these, see how it looks. Should be good to go. Printer starting up. I guess I'll wait. Maybe I'll pause. Or I could take this time and just talk about kind of how 3D printing works. We'll jump back to the camera. There we go. Again, right in my face. So 3D printing, at least FDM, which is fused modeling, basically works the same way as an inkjet printer, where you lay down a layer of color and then you lay down another layer of color on top of that, except when you're working with 3 dimensions, you're using plastic, so filament. You can actually 3D print with anything that you can melt and then returns to solid at a certain temperature. So if you imagine, like chocolate, it's a liquid at a certain temperature, and then at room temperature it solidifies. There are different ways to cure it as well, so you may not have to use heat or I guess coolness as your factor, but most of the hobbyist 3D printers use either PLA or ABS plastic, so that's going to be a filament. Looks usually comes on a roll, might look something like this, but it's essentially like a spaghetti noodle of plastic that they then melt at a certain temperature and then push through a nozzle, and then as it pushes through a nozzle, it'll create different patterns in 2 dimensions, so an X and a Y. If you remember your geometry from high school, so you have your X across and your Y front and back, and then you lay down a picture of something, and once you lay down that picture, either the bed will drop or the nozzle will lift up, and then it'll do the same thing over top of that. So it just builds layer by layer until you end up with a 3D printed part. So there are some limitations to 3D printing too. You can, I guess some of the big ones would be time. So it takes some time to 3D print. We're not able to water cool it yet. There are different methods to print faster, but at least for most education purposes, you're using a hobbyist level or an intro level 3D printer. It's not as fast as producing things with injection mold or anything like that. And another limitation is the materials that we can use, and then the way that we actually build. So you notice the first model that I had, this material, support material, usually breaks away, and then you end up with a part. But when you design, you have to consider, is there something floating in the air? Because it won't be able to pick up on that, it won't be able to build that. Or is there something that is, at a steep angle, because it can't build out over open space, because when the filament comes out of the extruder, it's still molten, so it still is flexible and it'll drop off of things. So when you print, a pretty good, I guess, rule of thumb would be it'll do about 45-degree overhang. So it'll print out over itself as it climbs. And for every layer up you go, you're going to have a little bit more deformation. So your model isn't going to resemble exactly what it's supposed to be, especially at these level printers. You can generally, I usually up the sizes between fits. So you have stuff like tolerance. I usually go up about 5%. So whatever your size is, I'll assume that it's going to be about 5% bigger than that. And then that accounts for different ways that the model might deform as the print happens or after the print happens. So when you build, you have to consider, how do these pieces go together? There's no such thing as a perfect part. So if you have 0 tolerance, so if you have a 1/4-inch hole with a 1/4-inch dowel, it's not going to fit. So you have to play around with the sizing, and that's just going to be either practice. I'm sure there's probably something online that helps as a guide, but like I said, I usually just use about 5%. And when you design, not only do you have to consider, what is the end use, how do we build it, how do we assemble it, and then how can you post-process? So post-processing might look something like acetone smoothing. That's where you take acetone and you put it in a mason jar with a part, and the acetone actually melts the surface and it'll smooth it out, so you get different imperfections in the layers that are smoothed out. Your surface looks a little cleaner. You can also just sand it. with a nice high grit sandpaper. What another way to post-process? I mean, you can cut it and use something to melt it, maybe, because it is plastic. So you can also drill through it. You can process it like most normal plastic pieces. So yeah, that's how I generally go about printing and processing prints. So let's go back to this screen now that my printer is ready to go. I'll send that and begin my print. So hopefully that helped. I don't even know if I'm going to share this. I just kind of did it because I wanted to improve my design. Design takes iterations. Like, you're not going to get the perfect part the first time. Even the best people don't. So I usually start with a small piece to check the sizes. You know, am I accurate on size? Am I accurate on shape? And then I'll take whatever, I guess, faults that are in the design, and I'll try and improve those in the next iteration. And the nice thing about 3D printing is you can run through iterations really quickly. You don't have to send it off to somebody to produce, to, you know, mill it out of metal, or to create a mold for it so you can injection mold it, or to craft it out of wood. You can just have your design, print it, test your design, and then iterate based on that. So it really cuts down on your time between iterations, and it really makes it a lot easier to improve and test designs quickly. And I guess that's the whole point of rapid prototyping. So thanks for listening. I'll probably be back with another iteration of this because I'm sure I didn't get it right again. And then I'll test that, and then hopefully by the end of this I'll have something to actually show.